Decoder is a combinational circuit which has which has many data inputs, and and many outputs, many outputs. So decoder is used, decoder is used where we have used the decoder. So decoder is used to convert a binary to other other code, such as such as you can convert binary to octal, binary to octal. You can convert binary to uh, hexadecimal, binary to hexadecimal. You can convert BCD to decimal, BCD to decimal. Yes, that means a decoder is basically used to convert from binary to other code. It may be binary to octal, binary to hexadecimal, BCD to decimal. Yes. So up to this point, anyone have any doubts, any query? Yes. What is decoder? Decoder is a combinational circuit. Decoder is a combinational circuit which has many data inputs and many outputs. And basically, decoder is used to convert a binary to other code, such as binary to octal, binary to hexadecimals, BCD to decimals, so on, etc. Yes, is that clear?
Yes, sir.
Okay. Now, in a decoder decoder can be used can be used to decode can be used to decode and and generated a chip select signal, chip select signal. So in the case of chip select, where we have represent this one as CS bar, or somewhere the written as CS. CS. This chip select we have written like this one is CS like this. So what is the meaning of CS bar? So in this case, the bar means here the meaning is active low, active low. And when the simply CS, this means active high, active high. CS is the chip select. So decoder can be used to decode and generate a chip select signal. Chip select signal. If when we have written or when written as a CS bar, that means this one is a active low, and if only CS, that means active high. Up to this point, anyone have any doubts? No, no. What is the block diagram of decoder? Decoder. So first, now I'm discuss 2:2. This one is a decoder. So here the 2:4. So two input, and a four output. One, two, three, four. output, and one is enable line. Enable line. So this is called an enable line. And input is suppose A and B is the input, and output is suppose this is the first, second, third, and fourth output. So simply this is called a 2:4 decoder. 2:4 decoder. That means 2 input, 4 output. And this line is called enable line. Enable line. So what is the output and what is the internal circuit diagrams of that one? So what is first we have draw the truth table of this circuit. So when you have write down here the truth table, so this one is a truth table. So first I'm writing here the enable line, and then data input. So that is this one is input, and this sections that one is output. These all are the output sections. Outputs. So enable, then input is I'm writing here A and B. So I'm writing AB means A is more stable, that means MSB bit, and B is the LSB bit. And then output is Y3, Y2, Y1, and Y0. So this is the output of a truth table. Yes. So meaning is, so when the enable line is 0, suppose the enable line is 0, 0, that means low. Enable line is 0 means low. In that case, whatever any value of A and B, any value of A and B, output is 0, 0, 0, 0. So output is 0 when the enable values is 1. Yes. And when the enable values 0, when the enable values is 1, in that case, this value, this decoder depend upon this input, data input. So A and B, so it's maybe both is 0, 0. It may be A is 0, B is 1. It may be A is 1, B is 0, or it may be both is 1, 1. So when the enable line is 1, in that case, these values is depend upon A and B. So when the values is 0, 1, 0, 0, so only this Y naught is enable, that means on. Otherwise, Y3, Y2, Y1, that is 0. Similarly, for 0, 1, only this line is enable. Uh, 0, 0, Y1 is high and other one is 0. Similarly, a 1, 0, Y2 is high and other one is 0. And Y3, so double 1, A and B is 1, 1, this is 0. So actually this is the truth table of your uh, 2 is to 4 decoder. 2 is to 4 decoder. Yes. Then write down the expression for what is the expression for Y naught? So just to solve this one, Y naught, what is the value of Y naught? What is the value of Y naught? So simply see that where is the Y naught? So Y naught, where is the 1? So this is a 1. So what is the value? Just to see that here. 1, 0, 0. So simply you can write down Y naught equal to, so Y naught equal to uh, A, B, and E. So A bar, B bar, E. Because 0, 0, 1. 0, 0, 1. So simply I am writing here the Y naught, that is equal to A bar, B bar, E. or this values is equal to simply a bar. Yes, simply if enable line that values is 1, then simply you can write down this is a bar, b bar, like this. Similarly, someone find it the what is the expression for y1. So y1, where is the 1? Only here is the 1. Just see that. So a is a bar, b is 1, and e. Similarly, when you have find it the y2, what is the value of y2? Where is the one? This one. That means a, b bar, e. And if you want to find it the y3, so y3 is equal to y3. So where is the one? So 1, 1, both is 1. So a, b, and e. So this is the output. This one is the output. So which gate is used here? Only AND gate. So when you have find it the values, so y1 is equal to a bar b e, y3 is equal to a b bar e, and y4 equal to a b e. So this is the values. So up to this point, anyone have any doubts, any query? Yes.
No, sir.
So what is the internal diagram of this decoder? So only input is just see that how to design this circuit. How to design the circuit. So here we have used the AND gate, and how many AND gate? Four AND gate, four AND gate, four AND gate. This output is y0, y1, y2, y3, like this. So this is the y0, y1, y2, and y3. So what is the input of just here I'm writing here a is the input, and then it's a NOT gate, that means a bar. And similarly I'm taking here the one input, that is the b, and connect to a NOT gate, b bar. Yes, and then here I'm connecting one enable line. So this one enable line, and just now connect to. So first input is a bar, b bar, e. So e is connected here. Then here we have connect the b bar and a bar. So what is the output here? A bar, b bar, e. Similarly, the second one, that values is a bar. So E, B, A bar. So here the output is A bar. Uh, so second one is not this one. Second, what is the second output? Second output is uh, A bar, B, E. So E and B, this one is the B, and A bar. So this is the A bar. This is the A bar. And the third output is A, B bar, E. So E is connected here, B bar is connected here, and A. And what is the Y3 output? That is A, B, E. So E is here, B is here, and A is here. So this one is called uh, 2 is to 2 is to 4 decoder. 2 is to 4 decoder. This is the internal circuit diagram. So when you have designed the 2 is to 4 decoder, so 4 AND gate is needed. 4 AND gate is needed. So when you have designing a mux, and OR gate is needed. When you have designing the demux, only AND gate is needed. And here you have also designed the decoder, you have needed only AND gate. So this section is the output. Everyone give your response. 8 output. So 3 input is, suppose A, B, and C. This one is the 3 input. One line is the enable line, and 8 output Y7. So suppose this is Y naught, Y1, Y2, Y3, Y4, Y5, Y6, and Y7. So this one is 3 is to 8 decoder. Is that clear? Up to this point, anyone have any doubts, any query? So how to draw the truth table? How to draw the truth table? Just to see that. And according to truth table, you have find it the what is the expression? What is the expression? So how to draw the truth table? So just a truth table is truth table. So here the input is first now I'm writing here the enable line. First writing the enable line, and then input. Input is A, B, and C, and then finding here output. So output is just a Y7, Y6, Y5, Y4, Y3, Y2, Y1, and Y0. So these all are the output. This one is the output. And what is the condition? So when the enable line is, when the enable line is 0, 0, what is the value? It does not matter what is the input ABC, output is always 0, 0, 0, 0, 0, 0, 0. Output is always 0. And then when the enable line is 1, that means high. In that conditions, this values is depend upon output, depend upon this input. Input is 3 variable, so 0, 0, 0. It may be 0, 0, 1. It may be 0, 1, 0. It may be 0, 1, 1. It may be 1, double 0. It may be 1, 0, 1. It may be 1, 1, 0, or it may be a triple 1. So when enable line is high, in that case this one is depend upon ABC. So what is the values here? So values is, so when all threes are zeros, only Y1 is high, other one is 0. Simply put here a 0. Similarly, when 001, that means only Y1 is 1, other one is 0. Similarly, put the 10, this values is Y2 is 1, other one is 0. Similarly, double 1, so only Y3 is 1, other one is 0. 1 double 0, so only Y4 is 1, other one is 0. 101, only Y5 is 1 and other one is 0. 110, so only Y6 is 1, other one is 0. and triple one. So only y7 is 1, other one is 0. Yes. So just to see that where is the diagonally this value is 1. Yes or no? So can you here the for the y naught? So this is y naught. Y naught. So here is the one, only this is the one. So you can write down the y naught expression. So y naught expressions is equal to a bar, b bar, c bar, a bar, b bar, c bar, enable lines. Yes. And if enable line is always 1, so you can consider this one is a bar, b bar, c bar. Similarly, what is expression for y1? So y1 equal to a bar, b bar, c. What is expression for y2? Y2 equal to a bar, b, c bar. Or you can write down here the enable lines. Up to this point, anyone have any doubts, any query? Yes or no? Is that clear? So this is equal to what is the value? A bar, B bar, C bar. Enable values is 1. Then so similarly you can write on y3, y4, y5, y6 and y7. Yes or no? So what is the logical expression for final values of y naught? So y naught is this values is a, b, c bar. Y1 is just a, b, C. So A bar, B bar, C. Y2 is A bar, B, C bar. Y3 is A bar, B, C. Y4 is A, B, C bar. Y5 is A, B bar, C. Y6 is A, B, C bar. And Y7 is A, B, C. Yes or no? Yes or no? So anyone have any doubts or any query up to this point? Yes, everyone give your response.
Yes, sir.
No,
Clear.
sir.
No doubts.
Clear, sir.
This way you can design any decoder circuit 2 is to 4, 3 is to 8, like this, 4 is to 16. In this type of any decoder circuit you can design. And also you can design how many AND gate is needed here. So if you want to design this one, how many AND gate? 8 AND gate. And input is ABC. So what is the difference here? So here the input is A, B, and C. Similarly, A, B, C. Then you can choose AND gate, 8 time AND gate, and finally output Y0 to Y7. So can you design now? Yes or no? Then questions is how to design. Questions is implement. Or anyone have any questions? Yes. Anyone have any questions? Implement half adder using using 2 is to 4 decoder. So using a 2 is to 4 decoder, you can design a half adder circuit. So how to design this one? So how to this is a half adder. This one is a half adder. Just to remember half adder, and it's the input is A and B. It's the input is A and B, and it's the output is sum and carry. So it's the output sum that is equal to A B bar plus A bar B, and carry that is equal to AB. So how to design this one? So here I am using a 2 is to 4 decoder, 2 is to 4 decoder. Yes, 2 is to 4 decoder. So input is A and B, input is A and B, and its the output is uh, y naught, y1, y2, and y3. Yes. So what is the output here? So output is, in this decoder, the output is y naught, y1, y2, and y3. Yes or no? So what is the output? Just 2 is to 4. What is the output y naught? So y naught is, what is the output of y naught? So y naught is a bar b bar. What is the value of y1? Y1 is a bar b. What is the value of y2? That is a b bar. And what is the value of y3? That is a b. Yes or no? Here I'm as you choose the value enable line, that is the one. Then how to find it this expression? So one OR gate is needed. So just you have connect here one OR gate, OR gate. So what is the input of OR gate? Y1 is the input and Y2 is the input of OR gate. And then this output is called sum. Sum. And carry. So carry is just a Y3. So this Y3 is simply called carry. Carry. So this circuit is, you can design, implement a half adder using 2 is to 4 decoder. So this is a two. This circuit is a half adder. This one is a half adder using 2 is to 4 decoder. So are you understood? Yes or no? Or anyone have any doubts, any query?
No, sir, no doubt.
So if someone say implement a implement a half subtractor. Suppose say the implement a half subtractor, then using 2 is to 4 decoder. So what is the needed? Sum is same. Sum is same. A b bar plus a bar b. Sum is same. In the subtractor, one borrow is needed. Borrow is needed. Yes. And what is the expression for borrow? So when you have subtract a minus b, so it's the expression is a bar b. Yes or no for borrow? So where is the a bar b? So this one is the a bar b. So here you can say this is a borrow. So using implement, you can implement a half adder or half subtractor using 2 is to 4 decoder. So this is your circuit. Or anyone have any doubts, any query? Yes or no? If anyone have any doubts, any query, everyone, can you implement a full adder or full subtractor using a decoder? Yes. So first, now here, draw the expressions. So just to see that what is the full adder. So this is a 3 is to 8. This is called a 3 is to 8 decoder. So how many inputs? Three input, A, B, and C. This one is the three input. And how many outputs? So output is Y naught, Y1, Y2, Y3, Y4, Y5, Y6, and Y7. So just I'm writing here the Y naught, Y1, Y2, Y3, Y4, Y5, Y6, and Y7. So this one is the output. So total output is this one. Yes or no? And everyone know what is the logical expression for y not y1 y2 y3. So for you have used the summation, you know the full adder expressions. So full adder expression, where is the mean terms for sum 1 2 4 7. So here you have used the one OR gate. So this one is give odd expression for sum, and you have used the another OR gate. This one is give your expression for carry. So just see that here when you have draw the full adder. So just now I'm compare here the full adder. So 1 A B and C, this one is the input, and here the output is sum, and this sum equal to mean of 1 2 4 7. Just to see that. And carry equal to a mean of 3 5 3 5 6 7. Yes. So only these values. Yes or no, or anyone have any dots, any query? So where is the one? So this is the one. So this is the input of our OR gate. Where is the two? Input of OR gate. Where is the four? Input of the OR gate. And seven, input of OR gate. Similarly, for carry 3 5. So 3 5 6 and 7. So this one is a OR gate. This one is the OR gate. So you can say this is a full adder using 3 is to 8 decoder, and this is full adder. So FA means full adder. Full adder. So up to this point, anyone have any dots, any query? Yes or no?
No, sir.
Everyone give your response. Are you understood or not?
Yes, sir.
Yes, sir. Understood.
Okay.
No doubt.
Then lower order. So just to see that how many. So suppose the question is 4 is to 16 decoder. 4 is to 16 decoder. I want to design this one is a decoder. So how many 2 is to 4 decoder is required? How many 2 is to 4 decoder is required? Similarly, suppose I'm writing here simply how to find it. Just so no need to see that this 4. So only see that 1 cross 16. So only what is the value of 16? So 16 divided by you want to convert this one 2 is to 4. So 16 divided by 4. So what is the value? 4. And again 4 divided by 4. So what is the value? 1. So you can say a 5, 1 plus 4, that is equal to 5 decoder is needed. 5 decoder is needed. Is that clear?
Yes, sir.
Yes, sir.
Similarly, suppose if you want to design a 4 is to 16, question is a 4 is to 16 decoder, 4 into 16 decoder, just a convert into so what a 3 is to 8 decoder. So how many decoder is needed? So just no need to see that what is the value of 4. What is the 16 and here 8. So 16 divided by 8. So 2
Two.
and then 2 divided by 8, that is 2 divided by 8. So this one is considered as one decoder. Yes. So how many decoder is needed? 1 plus 2, that is 3
3.
decoder is needed. Are you getting?
Yes, sir.
Or someone say 4 is to 16 just work like 1 into 16 and then 16 into 1. So just now I'm consider only this one. No need to see that the 4 or 2 or 3. No, that because this 16 is the output. Here 4 is the output. 8 is the output. 6, this 4 is not a output here.